we want to look at one more thing with regards to heat transfer and make some of this a little bit more real. So here is a snapshot of my electric bill. This is my over the last year. You can see I'm doing better this month than last year at this time, mostly because it hasn't been as cold yet, or it's been warm, or it's been colder. I don't know which, but I'm doing better this year than last year. So here I've used 2503 kilowatt hours of energy. So what we pay for in our electric bills is not power. What we pay for is energy, which is power times time. And let's break apart what a kilowatt hour means. A kilowatt is 1,000 watts, which is 1,000 joules per second, right? 1,000 joules per second times 3,600 seconds per hour is 30, let's see if I can parse that out, 3.6 million joules per hour. Right, joules isn't a great unit for doing this, which is why we use kilowatt hours, right? But if we look at what 1 kilowatt hour is, 1 kilowatt hour is 3,600,000 joules of energy. That's a kilowatt hour, right? And that's what we actually pay for. And if you look at my bill, I'm paying about 9.3 cents per kilowatt hour. So my October bill, 2,503 kilowatt hours, ended up being about 233 bucks. Okay, so what does that mean, or why are we talking about this in the context of heat flow, right? Heat transfer, R values, and all that kind of stuff. Well, let's think about a typical window in a house. Now, this isn't my house because, as you guys know, there's not a lake like this in Cleveland, Mississippi. This is just a random window I grabbed off the internet. All right, so the area of a typical window like this is about 2 square meters. The R value in US units for a single pane window is 1. It's a typical R value for a single glass window. Well, to convert that to the metric units we need for these equations, we divide by 5.678. Not a terribly hard number to remember, right? Okay, so we divide that by 5.678. And so let's say it's 10 degrees colder outside, right? So we've got our equation. I'm going to flip back to it. We've got our equation here. It's 10 degrees cooler outside, so T2 minus T1 is 10, right? The area we've already said is 2 square meters. This is 1 divided by 5.678 to convert it into the right units, right? So we're going to go down and we're going to look at that again. As soon as I can get it to do that and not crash. Okay, there we go. Get back down here. Where are we? Right here. So we're going to put all this together. The 2 square meters times the 10 degrees difference divided by 1 over 5.678. And I get the heat going out of my window, my 2 square meter window, is about 114 watts. All right, 114 watts. 114 watts is a really bright incandescent light bulb, right? That's actually a fair amount. So what does that add up to? All right, we're going to go back over here. We're going to take a look. What would I pay for this window in my house? And I have a lot of these in my house, by the way. They don't look exactly like this, but they are old single pane windows. All right, so 1 kilowatt hour is 9.3 cents or $0.093. Or we can write this as 1,000 watts times an hour is $0.093. For this window, 114 watts times, okay, I'm just going to divide through by that to get the conversion, $0.093 per 1,000 watt hours. And that's going to give me $0.0106 per hour. All right. So that's what? A penny an hour, right? A penny an hour is what I'm spending on my window, right? On one of my windows, and my house has, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, Oh, 15, 16, 17, 18, 19 windows about like this, right? Um, I have a lot of windows about like this. So when I look at this, okay, you say just a penny an hour, but a penny an hour times 24 hours a day times 365 days a year ends up being $93 a year. So a single window, even if it's just mildly different, 10 degrees difference between inside and outside, a single window is $93 a year. All right? Pretty amazing, isn't it? Now, here are some things. If we go and we double the R value, this drops by a factor of 2, right? So a double pane window cost me half as much per year, right? So this is why windows make an enormous, and windows are one of the primary sources of loss for heat going into or out of a house. So just a quick study on what does all this mean and how does it become kind of practical? Where does it meet the road? It meets the road right there when money starts going out of my pocket. All right, there you go. That's the last bit.